Hi students, good evening. Today we are going to derive the expression for work, and for that we have to consider a cylinder in which a piston is attached. Okay, so this is a piston and inside it air is there. Okay, is it clear? Then here outside also air is there, as you know. The piston will move inside the cylinder when the pressure outside is more than pressure inside. Is it clear? The piston, this is the piston, this piston will move inside when the air pressure outside is more than the air pressure inside. So like that, if it moves inside, there was a initial volume. Suppose this is the initial volume. It had V initial, Vi number of volume. Okay, then after the piston is pushed here up to this point, suppose this is the volume. As you know that air is compressible, so Vf is the final volume. Now you know that volume is given by L cube, isn't it? L into L into L. So this is the L. Okay, the length is considered as L. So volume change is given by L into L into L. So L cube. Now there is a cross-sectional area here, and that is given by A. So L into A is volume change, because area, you know, it's L into L. So in place of L into L you can put A, area. Is it clear up to here? Next, pressure. Pressure formula is force by area. Is it clear? Now force equal to P external. We have considered this P. Suppose it is P external, then force equal to P into A, P external into A. Now work is defined as force into displacement. So the force is given by P external into A and D. Okay, so this is the distance P D. Next, P external, so area into distance, what you have got? Volume, right? Means this is also L, this is also length into length, area length into length, distance is also length. So 3 length you are getting. It means what? Volume change, and your volume was delta V. Okay, delta V. Now from where this minus has come? See in the diagram, initial volume was more and final volume was less, because the piston was moving, was pushing the air in towards the bottom, right? So the volume is less. So from smaller number, if you subtract the bigger number, you will get a negative quantity, isn't it? It's like 3 minus 5, what you will get? You will get minus 2, na? So from the smaller one we are subtracting the bigger value, that is why minus delta V. So this delta represents the difference. Okay, now bring this minus in the front. Okay, now as the piston was moving inside, it was not moving with a constant value. The pressure was not constant throughout the journey. The pressure was little bit, it may be 1 atm, then it may be 2 atm. So like that, the pressure applied by the external air was not constant throughout the journey. It is similar to the example that you are traveling to a place, and during your journey you are speeding your car, sometimes you are slowing it down, so your speed was not constant throughout the journey. Is it clear? So that is the meaning of it. Now if I want to calculate the average speed, not the average speed, actually the total speed, then what I will do? I will integrate, I will do the summation, I will add up all the speeds, isn't it? So here in chemistry and in mathematics as well as in physics, you will get a word integration. In general, integration means, theoretically integration means adding up, okay, bringing together or joining something. Okay, so compiling something, that is integration. Here integration is actually a function. It is a function, and there is a whole big chapter of integration in mathematics which you will learn, and so I will not go here in details. I will just say the formulas that are used here only. Okay, you will get so many formulas, but I'm not going to teach them all, just the formulas that are required here. Now what we will do, since pressure external delta V, so this thing you have got. Now we will integrate the right hand side and left hand side as well. After integrating, what we will get in the right hand side, you see integration symbol is this. Okay, the symbol is this. Above you have to write the final value. What is the final value? Vf. Initial value is Vi. Next, the term Pex dV. Integration of a constant, while integrating a constant, that constant into variable, that constant will be coming outside, because you see we are integrating some variables. We cannot integrate the constant that is fixed. Okay, so that this minus, which is means -1, na? So -1 will come outside the function. Next, P external equal to P internal plus dV. This dV signifies very small change in volume. Okay, this dV, sorry, it will be dP, not dV. So dP. P external is equal to P internal plus dV. We have already said that P external is greater than P internal. Okay, so by how much it is bigger? Because you see, in order to push the piston inside, the outside pressure has to be more than the internal pressure. By how much it is more? It is little bit more, not too much. So that is designated by, again I'm writing V, so dP. Okay, so this is designated by a very small change in pressure, or very infinitesimally means difference in the pressure, that is dP. Now you see here, again we have written minus integration of F, then Vi. Now you will use the associative formula. What is the associative formula? If x was here, y plus z, then you will write xy plus yz, xz, sorry. Okay, so this is the thing, this is the associative formula. Here also you will use the same thing. Okay, you will multiply dv with P internal and dP. Now you have multiplied P internal and dV. Okay, now you will multiply dP and dV. As I have said that D designates very small change. Very small change means what? Suppose if I am taking 0.1, again another very small change, 0.3, what I will get? 0.03, which is again smaller. So when you will multiply very small term, you will get more smaller terms. So 0.1 and 0.3, this was okay, small, but while multiplying these two, you have got a much less value, right? So 0.03 is very less than 0.1 and 0.3, so you can almost neglect this one. It means while we have multiplied dP, which is already small, again we have multiplied dV, which is small, so dP into dV will give us a value which can be neglected. Okay, which is like very small, so you don't have to write it. What is left? Only this part is left. P internal into dV is left. Clear? Now in the states of matter chapter, you have learned that PV equal to nRT. So P, what you will get? nRT by P, right? So instead of integrating Pi and dV, instead of P, what you will write? nRT by V. Let me show you. You will write, instead of, it was P dV. Okay, so P internal I am skipping for now. nRT T by V dV. Clear? Next you see R was gas constant. It is a constant term. N will be constant, 1 mole. Suppose N is 1 mole, that will be constant. T will be constant when, in which process? In isothermal process. So you can say that nRT is constant. That is why you can bring outside the bracket here, nRT integration dV by V. Is it clear? I'm not writing the values here. Now you see nRT this can be written as L, and already I have written here, you can see. You can write ln V dV by V. Clear? ln dV by V. Now this is ln, and I think so you know the word logarithm. So logarithm, its logarithm, the base is 10, and for natural log the base will be e. Okay, so we are not going to go so much in details, but if you have to convert ln to log, you will use nRT into 2.303 log of V final by V initial. So this is the formula for work. Clear? When we have removed the integration sign, see, we have to remove the integration sign now. How you will remove? You have to write here ln V final by V initial. Clear? So this ln can be converted to logarithm, that is by using the term or the value 2.303. It's like you have taken 1 kg and you want to convert to gram. Then what is the changing value? What is the term? 1000 gram, right? Similarly, when you will convert ln to log, you have to use one term here, 2.303. If it is ln x, it will become 2.303 log x. Is it clear?